And on the seventh day, he got to work. Happy Sunday morning, everybody. This is the beginning of a big episode right here, hopefully. I guess if you're watching it, it's a big episode. Because if you're not watching it, then we have failed dramatically. Anyway, before we get to the topic of today's program, here's the 5E3 Deluxe head that we built. I don't think I documented a couple of things in the Let's Build video. We have, on the bright channel, selectable bypass capacitors. So when you have it in the up position, it's normal according to the traditional 5E3 schematic, 0.1 microfarad capacitor. And that allows a lot of bass to get through, and it gets flubby and yucky, and especially with like a humbucker pickup. So you click it down, and I forget the value I use, but it cuts out, you know, a good portion of the bass, and it tightens it up and cleans it up. Makes it sound nice. And if you watch the Tom Petty video I did, I think this is a excellent sounding recording amplifier and playing around the house amplifier. I was very, very happy with this one. And what else did we do? Oh, needed something for the bottom, so we used a piece of Lexian. Can you see that? Probably not because it's see-through. But trust me, there's a piece of Lexian there, so you can see all the hand-wired point-to-point goodness. And then video 2 ago, we talked about, you know, where we're at and where we're going with the channel. And, you know, I like this amplifier so much that I thought we should build a prototype of a production model. But then I was talking to the Tone Princess. Hey, Tone Pet's going nuts. Anyway, I was talking to the Tone Princess, and she asked me, you know, what is it about what I do that makes it different from everything else that's out there? And I thought about that for a while, and the answer was kind of nothing.
What would you say you do here?
So we're going to change directions, and we're going to do something different than what else is out there. Something you really can't find. So we'll get got our coffee here. The Tone Nun needs to go shopping, so we're drinking swill. But I'll set up the action cam, and we'll do an overview of what this project's going to be about. So if that all sounds interesting to you, I'm not sure why it would, but if it does, stay tuned. Brought to you by CBS. Alright, so the mission for today's episode is we need to get all this crap here, and here into that box in a very particular order. And then it'll be awesome, right? I'll tell you what it is in a minute, but let's get some of the house cleaning out of the way here. This is a Hammond enclosure. I got all this crap from Amplified Parts / Antique Electronics / Tubes and More / CE Distribution. Here's the bottom plate for the enclosure I used. Here's the enclosure I used. If I was going to do this again, this is 12 by 8 by 2. I would have gotten it by 3. But we'll make it work. We will make it work. And then our transformers of choice. It's a transformer fit for a Tweed Deluxe. Output transformer. And look at this bad boy. We are not joking around here today. Overkill or no kill. 276X, there's all the stuff. Alright, let's set up the action cam and I'll show you what the plan is.
What's the game plan, Kevin?
Alright, so the original plan was to make a 5E3 Deluxe head, Fender Tweed Deluxe head, with, you know, a couple little mods on it, like, you know, switchable bright switches, the selectable coupling capacitors, and, you know, maybe negative feedback adjustment and stuff. But as I was playing around with that purple amp, the way it's wired, you can use metal tubes, and the voltage is a little lower from the Grom's little gem amplifier. The power transformer's got a little bit lower voltage, so it was ideal for those old school metal output tubes. And I really like the way they sound, and I don't know, I get excited about metal tubes for whatever reason. Probably because they're from like the 40s, so anyway, for the longest time I've been wanting to do a vanity project, and that's what we're doing now. I wanted to make the Prince of Darkness amplifier.
Call me Dad.
So what this is going to be, it's a combination of about 3 different Tweed era, or even prior to that, 3 different early Fender Deluxe amps, plus a little bit of Gibson GA30 stuffed into one, and it's going to be all metal tubes. So this is probably a recipe for disaster, but like I said, this is a vanity project that I've been wanting to do for a long time. Plus, we love a religious motif around here.
Popes, swamis, snake handlers, all feeding at the same trough. Whose ideas were those?
So any amplifier we can call the Prince of Darkness amplifier, you know, that's a win for me.
Yes! Wow!
All right, let's take a look at some schematics. Hopefully you can see everything here. This is the first schematic I drew up, my first idea. And channel 1 would have a 6SC7 preamp tube. Channel 2 would have a 6SJ7. And the 6SJ7 is actually a pentode. And the phase inverter, I wanted to use a 6N7. Basically because it's actually got a grid cap on top, and how cool is that? But I kept doing research and going through the tube amp book, and I finally ended up with this. So there's about 3 different deluxe versions, and a little bit, this section here is a GA30 input. So the inputs are pretty standard for what we use even up until this day, you know, with the 1 meg to ground, the 268K resistors going into your first preamp tube. On channel 1, we're going to have a 6SC7, which came from, if I could find it, okay, the Model 26, the old TV looking ones. And I think this one as well, yeah, the 5A3 has a 6SC7 preamp tube. And the 5C3. And once we get to the 5D3, they switch over to a 12AX7. Alright, moving on. Channel 2 is going to have the 6SJ7. And let me drag out the tube amp book so I can show you that schematic. Right, here's the tube amp book. Can you see that? No, you can't. You can't see it. I'll put it on the screen. Here's the tube amp book. And if you're into this kind of thing, this is an excellent book. I found this on eBay, I think, for a very good deal. Paid like 20 bucks for it. Alright, Gibson. No, we've gone too far. GA30. Alright, let me take you off the action cam here. Alright, so the bottom schematic here is the GA30 with a 6SJ7 preamp. And here is that schematic. And here is our 6SJ7. And, you know, it's going to have a screen resistor for high voltage, blah, 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 all that good stuff. So that's where I got all this stuff from. Alright. Alright, coming out of the first preamp tube. I like the mod I did on the Purple Deluxe, where you'll have selectable bypass capacitors, so you can have 0.1 micro, you know, going full blast, or you can switch it down to a more reasonable 0.02 micro, and that'll be on both sides. And then they go through their volume knobs. We got a tone knob. They mix together, and they go to a 6N7 phase inverter. I forget what this is called, a split phase, something like that. Phase inverter. It's not a cathode like the 5E3. I'll get the right kind to figure out what the heck this is. I get confused on it. It's not a long-tailed pair. It's not a cathode, it's the other one, whatever that is. And so that's from the Model 26. And 5A3 also has the same phase inverter. And the 5C3 uses a different tube, but it's the same thing. And then finally we get to the 5D3. Same thing? Yeah, same thing. The 6N7, the triodes share the cathode, whereas on a 12AX7, you know, each triode has its own cathode, so that's why it's drawn like that. And finally, when we get to the 5E3, it turns into a cathode phase inverter. So that's our phase inverter, 6N7. And then pretty standard stuff. Everything from here back is from these early deluxe models. A couple of 6V6s. Gonna wire the tube sockets so we can use metal tubes, obviously. And I'll explain why you shouldn't use metal tubes on certain amplifiers. And then blah blah blah, regular amplifier after that. And finally, the rectification tube is going to be a 6x5 because they don't make a 5Y3 in a metal envelope. So we're going to use a 6x5, and the power transformer will have no problems handling all this stuff. It could probably handle 2 amps at once. You know, we can make a stereo amp with all the same stuff, and this would probably work. So it's a little bit of overkill, as you can tell. But there you have it. And then finally, I drew a sort of layout of how everything's going to work. Hopefully I drew it correct, and hopefully this all works. You know, I guess a good analogy is, you know, a lot of people ask if a guitar player has been classically trained. You know, and a lot of our favorites have not been. I am not a classically trained amp builder. I just kind of, if it sounds good, it is good. So hopefully it sounds good, hopefully it all works, and there's nothing to it but to do it. So with that, let's do it. Alright, so while we are unwrapping this, I will put on the screen my amplified parts shopping list. Pretty much has all of the components that one would need to build one of these things. If it works, that is. Not that you should, because electrical work is fucking dangerous and you'll kill yourself if you work on electronic stuff. So don't work on this at home. Don't do this yourself. But yeah, that's probably rolling on the screen as we speak. And alright, first step is to mock it up. Place all of the junk wherever you kind of want it. Make sure it's all going to fit. Kind of, you know, that kind of thing. And then we're going to mark it out, and we're going to drill some holes. We're going to install some stuff, and then it's going to work perfectly, and it's going to be awesome. Alright, here we go. Alright, word about these enclosures here. This is a Hammond enclosure. It's a steel one. And if anyone has a source of, you know, this kind of thing that's less expensive, that would be great. Please share it with the rest of us. This thing was like 35 bucks. These things are freaking expensive. But I chose this steel one. I watched a Clay de Jong video, and he made his Dumble head in an aluminum enclosure, and that seems to be really thin. You know, aluminum is great to work with, and I think, like, what's his name, Mr. Fisher there, Mr. Trainwreck, he liked to use aluminum enclosures because it's a non-ferrous material, and supposedly steel sucks up all the mojo.
I have your mojo, and I'm taking it with me to the moon.
But whatever. But I went with steel because it's a little bit stronger, because this is still kind of thin. But because it's steel, it's nice and strong. But it looked like Clay was having some issues with, you know, the big giant transformers were kind of, you know, didn't suit it. So, yeah, we went with steel. Heavy metal, baby. Here's what I found to be the biggest problem with the enclosure that's only 2 inches high. Is, you know, you can't really stack these one on top of the other. It's just, I mean, you might be able to, but it'd be goddamn tight. So I'm going to put these like this. And that steals some real estate going here. Which, as you'll see, you know, with 3 knobs, a quarter, you know, a bunch of switches, indicator lamp, and your main power switch, you know, real estate. And the x-axis is kind of at a premium. They're kind of at a premium in every axis. But it's an axis of evil, but we will overcome. I forgot to mention the 6SC7 is a dual triode. And on the model 26 here, they are using each triode for a separate channel. Channel 1 goes through one triode, channel 2 goes through the other triode. We're going to do something a little different, since our channel 2 is going to be going through the Pinto tube, the 6SJ7. We are going to have it selectable for operation in parallel mode. So we'll be paralleling the grids together with a switch, and then everything else will be tied in together. Hopefully that's the best way to do it. I think it is. If not, we will certainly find out soon enough. Alright, going back to the discussion I had with the Tone Princess, and thinking about what I do that's different than everything else in the world. Oh, it's the cops. Shit.
All right, everybody, lock the doors, turn off the lights, pretend you're not here.
Anyway, sorry about the siren. What is different about what I do than what, everyone else does in the world? So hand wiring, yeah, there's a lot of boutique builders and, medium-sized builders that hand wire, but not many people do real point-to-point wiring. I'm not talking about having an eyelet board or a turret board, but actual point-to-point construction. So people don't do that because it's a frickin' pain in the balls. And so, apparently we like torturing ourselves around here. But anyway, so kind of laying this up, and we have to bear in mind that we need to get as many components as possible to be able to go from point to point and to reach with their leads. So this is going to be preamp tube number 1 here, preamp tube, channel 1 preamp tube 1 here, channel 2 over here. This is going to be the pentode. And then we're going to have our phase inverter here. And this will be the rectification tube. And then our power tube. So this is tentative. And I think I'm going to put the input jack side by side. And then on the pentode, we'll have a selectable bypass capacitor. And then single triode or parallel operation on that tube. Oh wait, that's not that tube. See, this is why we do this. This belongs over here on the dual triode. And then same thing over here. We'll have the tone knob in the middle, selectable bright switches. And over here I just had a double pole, double throw, or double pole, single throw, but we got these guys here. And I think I'll keep them separate. That way they'll have individual, you can have bright on both, bright on neither, or one or the other. And I think we're going to put the power switch in back because we're running out of real estate up here. And we just have to bear in mind we need a little section for our filter capacitors here underneath. But yeah, I think this might actually work. And I got the orange drop capacitors. Oh yeah, another thing about this, we spare no expense. We get all the good stuff. Switchcraft, jacks, Carling switches. These aren't Carling, the blue ones, but those are going to be replaced. And if you're buying switches, the Amazon specials, the thread is a coarser thread. So all the nice dress washers I bought don't fit on these. So these will be replaced with Carling. So what we got here, Switchcraft. These are the Belton Michael-X tube sockets. High quality indicator lamp thingy holder, high quality fuse holder, and this is much better than the crap you get on Amazon. CTS potentiometers, Carling switch, going with this kind of plug, orange drop capacitors, F&T capacitors, and Mallory. So yeah, we spare no expense on this sucker. But anyway, yeah, that's another thing we do that a lot of people don't do. This is all high quality shit right here.
God damn, Jimmy.
We're not joking around. But anyway, yeah, lay it out. Got to kind of visualize in your head. And what I like about these orange drops is they got nice long leads, so we can go practically halfway across the chassis if we had to. But that's what we're doing. We're just thinking, making our brain hurt, and hoping and praying it all works out. And to really illustrate that point, so on our input jacks here, we have 68K resistors that connect the input jacks to the preamp vacuum tube, and that's going to pin 4. And the way we're going to orient those, so this is pin 1, 2, 3, 4, right there. That way, they won't be crossing over, a bunch of other stuff to reach where they need to go. So it's just little stuff like that, real attention to detail when you're doing this kind of thing. And this is why we do prototypes, because it's not going to come out perfect. I guarantee you that. But the you work out all the bugs on the prototype, and then I guess you have a prototype. Good times. All right, we've got the mock-up, and I think this is how it's going to go right here. Like so. And I cut out a piece of cardboard as a template for the front control surface of the chassis. And I had everything lined up as you saw before. And I just marked the center line of the outermost jacks to make our measurements and drill our holes. And from this point to this point, everything's going to be symmetrical. So we'll break out a ruler, or a scale, if you will. And now we'll try and make it look nice. So this is it. We're starting to commit. There's no turning back now. Here's our template for the front of the chassis, the control panel area. There we go. And we used imperial units, not silly meters. Alrighty. And we'll just put all the crap on the template again to make sure it's all going to fit before we start drilling holes and ruining this thing. Here we go. That all looks good. I think that'll work. And this is going to be the top up here. Put the input jacks on top rather than the bottom with the switches underneath, because we need to get those 68K resistors to the tube, which will be sitting right above it. And then probably have to use some wires here. It's not going to be a 100% point-to-point. But get some wires going from the bright switch to tone knob. How do we want to do this? I might move it over here. Oh, we're wrecking it. Bright switch to the tone knob, and then this one will be parallel operation for the dual triode indicator lamp with a nice, you see that? Oh yeah, that's going to look sweet, right? Anyway, yeah, I think that'll work. So we'll tape our template to the front of this. We'll break out the Ryobi, or the Makita, or whatever we have here. And we will deface our chassis. Alright, a little more insight into the thought process behind this setup here. Again, I am not classically trained. We're just kind of winging this, doing the best we can. But we want to facilitate the point-to-point build. So we're going to have our first preamp tube over here for channel 1, which is going to be the pentode. And we're trying to keep that away from, you know, all the power transformer and all that noisy stuff over there, because pentodes are known to be a little bit noisier. So he's going to be over here. And then over here on the top is going to be the preamp tube for the second channel. So that's why I did it that way, with the knobs in the middle and the jacks on either side, because all the connections need to go to the third tube, which is the phase inverter. So they're all going to be aiming like that. But here's the template taped up to the face of the chassis. We're going to break out the drill, mark our pilot holes through the template, and then have at it. Alright, we have our little pilots here, and they all look pretty good except for these 4 here. It looks like the thing was twisted a little bit that way. So I'm going to try and drill little pilots to twist it back to where it was. Don't know if I'll be successful, but worst case scenario, it's not too bad. But we'll try and make it right. Yeah. She's looking good. So the holes for the jacks and the CTS potentiometers are 3/8. And then for the little Carling switches, they are 1/4 of an inch. And if you're doing this at home, you're playing the home game, clean up your metal chips early and often. Because if you have chips everywhere and you're pushing this down as you're drilling it, you'll scratch the shit out of the finish of your enclosure here. So we drilled all the holes, then we went back with the step drill and cleaned up the jagged edges, put a tiny little chamfer on the front, but the drill won't fit in the back, so we're just going to get a Dremel tool and grind off the sharp edges from the back. Make it nice and pretty and smooth, no jaggies. Alright, I got all the junk temped in here, and I think she looks pretty good. We got channel 1 high and normal input, channel 2 high and normal input. We have base cut for channel 1, base cut for channel 2, parallel operation for the twin triode. And then we have bright switches for channel 1 and channel 2, channel 1 volume, channel 2 volume, and a tone. Yeah, I think that'll be nice. That'll work. Alright, moving on. Alright, we have all of our front-facing controls temped in. And now it's time to think about where to put all the tube sockets. There's a whole bunch of them. What is there, like 6? 1, 2, 3, 4, 5, 6. Yeah, 6 of them. And just want to make sure there's enough room from the front of the chassis here. We're not in silly meters. And if we look here, if you can see that, we need about 1 inch from the front of the chassis before it hits, you know, the furthest thing that's sticking out, which is the hot lead of our input jacks. So at least 1.25 inches, we want those back. So we'll keep that in mind, and I think we'll basically do the same thing. We'll cut out a piece of cardboard, same size as the top of the chassis. We'll put all our stuff on there, and then make our measurements to drill all our holes. So yeah, that's what we're going to do. Alright, so we very carefully made some measurements, and I will put the stuff back up where I made the measurements one last time to check it, to make sure everything's going to work. And we're not going to cut the holes for the power tubes just yet. I want to get the stuff on the rear face of the chassis installed first before I make a decision where those are going to go. Yeah. So let's take one last look at this, and then we'll cut some big holes. Alright, here we are, and I drew this guideline right here as a no-go zone, checkpoint Charlie, to make sure there was enough room for the controls and the input jacks and stuff. And all the preamp tube sockets are behind that. And yeah, this is how it looks, and that should work. And we got to remember on the inside we need to leave an area for the filter capacitors, but there should be plenty of real estate in here for those. Just might have to get a little bit creative. Alright, so I'm going to drill some pilot holes in the centers of the marks that I made, and then we'll do something really cool. Hang tight, you don't want to miss that. I don't want to miss that. Okay, so in the past, to cut the holes in the chassis for the tube sockets here, I first used a hole saw, and that was a horrible nightmare. Then we went out and we bought like a $60 step drill. I think this is a Milwaukee, and that worked better. And of course, it depends on what material your chassis is made of. This would probably work pretty good on this. It's kind of thin steel. It's mild steel, I think. It's not hardened or anything or stainless. So this probably worked pretty good. But I was watching Fazio Electric YouTube channel, and she uses a chassis hole punch. Who would have thunk it? So I got one of these on eBay. I think I paid, like, with shipping, it was like 15 bucks, and it's a Greenlee 1 1/8. I believe that's the right size for these Belt and Michael X sockets, but putting it up on the ruler, it looks like 1 1/8 and a 1/16. But this little punch out was still inside the hole punch from the last user. And if we put it up to the bottom of the tube socket, yeah, this might work. There's only one way to find out. Now, I was hoping to use a socket wrench, but it looks like the bolt was meant for a crescent wrench. I don't have a crescent wrench. I'm not a fucking plumber. But, we'll figure it out. Alright, we have some good news and we have some bad news. The good news is the chassis hole punch tool works amazing. I don't know how I lived without it. Bad news is, need 1 1/4 inches, not 1 1/8 inches for these Belt and Michael X. So what I think I'm going to do is I'm going to go back on eBay and get myself 1 1/4 inch one to cut all the rest of the sockets. Because this is close and I could hog it out, but you know, it's going to look shitty. And I mean, it looks so beautiful right now. It doesn't deform the surface at all. It's just absolutely perfect. So we'll order one of those. And I also want to order some more Belton switches so I can replace these Amazon ones. So they'll have the the finer thread, and I'll be able to use finish washers. And there's a couple other parts, so I need to put in a couple of orders for some stuff, because when I ordered all the parts, I was still on the regular 5E3 circuit, thinking I was going to build that, and then, I made some changes, obviously, to make the Prince of Darkness amp here.
Well, the Princess of Darkness, anyway.
So we're going to put in an order. We'll probably get back to this next weekend, and probably be right after a SpongeBob card for you. So hang tight for that.
A few moments later.
Stop the presses. We are back in action here. Bam. I went digging around and I found this old bigger step drill that I had. It's a cheesy Chinese one, but we only need it for the last step. So we don't have to wait for the new chassis punch to arrive in the mail. We don't need to wait until next weekend. We can keep on keeping on. It's not going to be as pretty, but it will work. And this is good because I actually took tomorrow, Monday, off from work, so I could either get a large chunk of this project or actually finish the project done in one weekend. I doubt that's going to happen, but we took tomorrow off anyway, so we would have just been moping around, crying in our soup. All right, we're back at it. Here we go. All right, so we're moving right along here. We're giving the old drill, what is this? Giving the Ryobi a good workout here. A lot of drilling through steel. Got the preamp and the rectifier tube all mounted, and I've got them all oriented to hopefully best facilitate a point-to-point build. Got some markings here for the power transformer. And right now we're working on the crap on the back. So we've got an IEC power plug. It's going to go like this. And when you install these, you want this middle wire, or middle conductor, whatever, your equipment ground and conductor, green wire, facing up. I know a lot of people think that's upside down, but it's not. It's downside up. And we're going to have a fuse, we're going to have a switch, we're going to have a impedance selector, 4, 8, and 16 ohm impedance selector knob here, this guy here, and then our output jack. So right now I'm going to break out the skill saw, and we're going to hopefully cut out a hole for this guy. It's got a weird shape. It has radiuses on the bottom and then corners on the top, but there will probably be a drum lid involved with this at some point, but we'll get it done. So there you go, moving right along. A little break out here with the tone pet. See, the corn's finally coming up, just in time for winter. Hopefully it'll be enough to last. I'm gonna shut up his butt. Where you going? Uh-oh. Going hunting. Oh yeah, here we go. Alright, I'm glad that's over. Not the prettiest thing in the world, but no one is ever gonna know. That'll be just fine. I wonder if they make some kind of hole punch, like an IEC plug chassis hole punch type of thing. I imagine it would have to be keyed somehow so the top and the bottom could align properly, but if that has not been invented, when you invent one, I'll buy one for sure. I guess a CNC milling machine would be good for this too. Speaking of D-Lab Electronics, I've been watching Mr. Carlson's Lab a lot lately. Oh, can't see who it is. Enjoying his videos quite a bit. Looks like a lot of you guys have too. But I was jealous when Terry from D-Lab had a Bridgeport in his house. This guy's got a friggin' aerial boom truck to go up on antenna wires.
So, in order to do that, we need to use the bucket truck over here.
That is some hardcore shit right there. But excellent videos. I've been learning a lot from these videos. So check them out. Okay, we've got all our holes for the power transformer. These outside holes are for the mounting of the transformer. And we have 2 3/8 inch holes to pass the wires through the primary and secondary. And it's very important that whenever you pass wires through a metal hole, that you use a grommet of some sort. I'm going to use rubber grommets here. And it's also important to, after you drill your holes, make sure you deburr it. Because that will chew through the grommet and chew through wire insulation, and then potentially cause all sorts of fireworks. Alright, we're almost done with the drilling portion of the chassis. We still need to cut 2 holes for the 2 power tubes, and I'll see if I can set up the action cam and demonstrate how well the hole punch works. It's going to be a little tricky, but I'll give it a shot. Here we go. Alright, so the hole punch has 3 pieces. You get a bolt, you get the bottom cup here, and then you have the top piece, the cutter. You can see that. And what you want to do is you want to put the outside cup in the bottom, because this will be pressing up against the chassis and it may mar the surface. So you want to use a non-visible surface. So that'll come into the bottom. Like so. And then we're going to screw this in. Alright, you want to make sure the bottom cup is flush with the surface, which it is. And we'll tighten this guy down. Okay. Now we'll get our crescent wrench, which I cannot locate, right here. And all we're going to do is just crank on it until she pops.
That's what she said.
And it's a little tough at first, but once it starts cutting, it gets easier. Oh yeah. Yeah, it's getting a little easier now. Alright, so one side is popped. We've got to keep going until it cuts all the way through. And there she is. Bam. Job done. And it hasn't bent the steel at all. The top surface is perfect. There's no burrs, no sharp jaggies. And the bottom, there is a little bit of a witness mark around the very edge of it. And it's slightly sharp, so you know, we'll dress that up a little bit. But yeah, this tool's a real lifesaver. And unfortunately, like I said, I got the wrong size. I got an 1 1/8. If you're using the Belton Michael X, you're going to need an 1 1/4. So what we're going to do to fix that is I have a step drill that goes up to an 1 1/4, and that ain't it. This one here, we're just going to go down 1 step, and that'll be that.
Tomorrow.
All right, we're back. Happy Monday, everybody. Just coming together. Got all the tube sockets in there, got the transformers on there. The tape is to protect the finish of the transformers when the chassis is laying upside down, like so. Here's the insides. Got a bunch of wires that we're starting to think about. Here's the back. Good stuff. Nice chunky power switch. Got our fuse coming together. Here's our potentiometer for impedance selection of the speakers. So yeah, here we go. Day 2. Got a lot done yesterday. Although I worked on it for like 10 hours, so stuff gets done. Just gotta throw time at it. Alright, what are we doing? I'm gonna put this guy up here. We're gonna land all of our power transformer wires here. and then do some soldering. So let's get at it. Let's skedaddle. We're moving right along here. Got the main power hooked up, primary of the power transformer. And we've got our heater system all wired up. And I'm not going to float them in the air. I'm going to have them lay down on the chassis floor or roof, depending upon how you look at it. Because we're going to have a bunch of other crap floating around up here. So I want to keep all that out of the way. But yeah, we're getting there. Time to hook up the secondary power transformer and start installing the passive components, which is always fun. Alright, little update. Did a bunch of work, mostly on the power section here. I think I'm going to get some foam and glue it down to the bottom there, and, you know, make sure these guys have some support. And then on the cover plate, put a little piece of foam in this area here, so these guys will be nice and snug, because they're kind of trampolining around, and we don't want that. But yeah, she's coming along. Got all the junk installed to the chassis. That's what all that looks like, if you can see it. There you go. She's coming along. Alright, back at it.
1 week later.
Alright, we are back. Saturday morning, weekend number 2 on this project here, the prototype of the Prince of Darkness.
Here's my card.
Ooh. The devil. Yep. That explains it.
Got a bunch of work done last weekend, and now I totally forgot where I was. But we'll figure it out. Get a bunch of stuff in here. We're going to put a bunch more stuff in here. There's the impedance selector switch, output jack, grounding. This is why we use a switch instead of, you know, like 3 separate jacks for the different impedances. You'll notice a lot of metal film resistors. When I bought the parts for this project, I originally was going to make a 5E3 clone-ish thing, but that since has changed, as we know. So I don't have all the good stuff in stock, so I'm using what I do have in stock, but that's fine. This is a prototype, and especially doing a point-to-point build, you know, don't know how it's going to look until you do it. I'm sure there's, you know, better ways of doing that. Some kind of computer program to draw a physical layout, but we'll figure it out. We'll get it done. The computer's beeping at me and dinging. All sorts of stuff is dinging. Holy shit, what's going on over there? But anyway, alright, so, yeah, let's continue on. Let's see if we can't get all this junk plugged into this chassis. Yeah, the most important thing I learned is we definitely want the 3-inch tall enclosure. You know, we got stuff, I don't like hanging stuff like this, you know, kind of sideways. And I'm going to go for the Mallory's. I do not like these orange drops. They're humongous. They take up a lot of space. They're radial, blah, blah, blah. I like the Mallory's better. But we have a couple of the orange drops in there, and they'll be fine. So, I'm going to try and figure out where I was, and then we'll proceed on from that point. So hang tight, here we go.
Several days later.
Alright, we're back. I believe this is weekend number 3 on this project. Didn't really do anything during the week. I think I finished everything up, connecting all the components last weekend, but I haven't messed with it during the week. I don't want it to, you know, fail or not work or blow up, and then I'll be all depressed at work. That would be bad. But, okay, so what we're going to do is we're going to check the schematic, and we're going to trace everything, make sure everything's plugged in that's supposed to be plugged in, and all the connections are soldered. And once we verify that, we'll hook it up to the current limiter on the variac. We'll dial her up, and we'll see what we made. Stay tuned for that. You don't want to miss it. Dude, what are you doing? You sunning your butt? Getting some bum sun? That can't be comfortable. What's going on here? I gotta fix you. Yeah, see? That ain't right. At any rate, come on, buddy. Fix yourself. Hang on, let Daddy help you. Okie doke. So we very carefully matched the schematic to the actual circuit in the amplifier. And I didn't miss any components. I didn't miss any connections. I did forget to solder two points, but we found those and we soldered those suckers up. So this matches that. And whether or not that's any good, well, that's the next step. Time to plug her in and fire her up. Here we go. All right, we're firing her up for the first time. And she's all fired up. I got her at 80 volts from the wall. You can't read that. 80 volts from the wall. It's not passing any signal. When I probe the plates on the output tubes, the speaker does, make some static, so we know that's working. But probing around here, checking voltages, and what I noticed is everything looks good. All the plate voltages look good, except for this guy right here. He's pulling like less than a volt DC. So I pulled the tube out. Here she is right here. Pulled out the 6N7 phase inverter. And now at that same point, now we're getting the voltage we should be getting, instead of like 0.8 volts. So, I think there might be something wrong with this tube. And I have multiples of every type of tube we're using in here except for 6N7. So I'll do a little more probing around in here, checking things. Maybe it's not the tube, maybe there's a stray connection, but it looks like, when I insert that tube, it's shorting the ground or something. I don't know what it's doing, but the voltage disappears off that plate. So, I think we might be at a standstill. Might have to order another phase inverter. I'll check around. I'll see if I have an alternative, a temporary alternative that's wired the same as the 6N7 that we can chuck in there, just to see if we can get her going and to troubleshoot. But setback. That's alright though. This is how we learn. Alright, I think I have discovered the source of the problem here. If we look at the pinout, pin 6 is the plate we're having trouble with. It's not getting any DC voltage, even though we're sending a couple hundred volts to it. And so I'm testing continuity on the pins to see if there's any shorts. And right now, so right there, pin 6 is with the red alligator clip. Pin 1 is no contact, or usually on the metal tubes, it's connected to the shell. So you just add a ground to that, and it acts as, a noise, whatever. Noise like a tube shield. And so, bam, we got 2.3K between that plate and the shell, which is not good. Which means we're sending all the voltage to ground, because I did ground all the pin 1s of every tube socket, so we could have grounded shells, tube shields. But even if I ungrounded it, 200 volts minus, 2.3K, we're energizing the metal shell of this tube. I don't think it's supposed to do that. Doesn't sound, well, it sounds dangerous to me. So, unfortunately, I don't have any substitutes, and I do not have, that's my only 6N7. And I'm not going to go rewiring this just to try a different tube. So, we'll get on eBay, we'll order some 6N7s, and then we'll pick it up hopefully next weekend. This is the project that just keeps on giving. Oh, and I don't think I mentioned this. I checked the other plate, continuity between the other plate and the pin 1 here, and there was over limit, no connection. So I don't think there's supposed to be any continuity between pin 6 and pin 1, because there ain't any on pin 3 to pin 1. It's hard to say. All right, we'll see you next weekend. Hang in there. We'll figure this sucker out. Sylvania, come on. How are you gonna let me down like that? Should have gotten an RCA.
RCA tubes cost you no more, and they assure you of the best pictures your set can produce.
One frozen wasteland later.
All right, we are back. Well, they're not quite back yet. It's Friday night, just got home from the silly day job. Check this bad boy out. Holy shit. Now this is what I call a barbecue. Damn. I can still sell the emblem for $5. Dead ass. And got some tubes here in the mail. Nice little selection here. And I believe in the previous clip I suspected the 6N7 that we're using as the phase inverter had an internal short to ground. And that's why the amplifier wasn't working. Hopefully that's the only reason. So while this Prince of Darkness amplifier project was on hold, I fixed up my Superior Instruments Company TV11 tube checker. And the third tube I checked was that SN7, and it showed that it had an internal short to ground. We put her on the tube tester, and wouldn't you know, we have a short. And then on the fourth tube that I checked, it failed spectacularly. It failed in spectacular fashion. The big 330 ohm resistor cracked and smoked, and it was a shit show. There was smoke coming out of it. There was so much smoke, I thought, like, you know, maybe a little coal had gotten down into the wood enclosure and it started a fire, and I was trying to find a screwdriver to try and get the damn chassis off to put the fire out. Yeah, it was ridiculous. Yeah, we got lots of tools around here. Tonepriest being one of them. But anyway, so we got a new selection of tubes, 6N7s. And this one's beautiful. Look at this bad boy. Pretty sure this is NOS. Has perfect branding. There's no marks on the base here from like a bear claw, bear trap. No witness marks on the pins. Nice Sylvania. Maybe Sylvania can get their reputation back here at the Tone Church.
Who turned on all the lights?
Ask for Sylvania, where the best comes to light.
What else we got? We got a nice Hytron. CBS Hytron. Starting to like these tubes. These seem to be very high quality. And I got a glass one because for the testing purposes, getting the thing up and running, we'll use as many glass tubes as we can. You know, we want to see any red planing and excess stray voltages if possible, and then we'll switch over to the blackness.
I've got a whole theme park full of red delights for you.
Once all the bugs are worked out. But yeah, nice Hytron 6N7. She's looking pretty nice. Looks like there's some heat on these pins, so this was probably used. Or not, I don't know. It's old. It's as old as Grandpa. Finally, aw yeah. You know we had to get an RCA. Oop, we got some nice classified advertisements. What can we buy here? Oh, cars. Fucking cars. It's the last thing I want to see after work. Bam. Oh, what is this? Oh, it's not an RCA. Got an RCA box. I guess that'll have to do. Stromberg Carlson, made in USA. Good enough. 6N7. She's looking nice. Alright, there you have it. Hopefully one of these is good. So, we'll pick this up tomorrow morning, hopefully. And, hopefully we'll get the Prince of Darkness running. We'll breathe some hellfire with our guitar.
The following day.
Alright, happy Saturday morning, everyone. We have the new 6N7 GT installed. I'm going to flip her over, we're going to plug her in, going to dial her up, and hopefully she works. So here we go. Come on, Sylvania, you can do it. Alright, we're trying to fire her up here with the new tube installed. No longer getting 0 volts on that pin 3 plate. We're right where we should be, but we're still not getting any signal. So I'm probing around in here. And when I probe the plates of the preamp tubes, you know, I can hear static through the speakers, so that's a good sign. But I did notice a mistake that I made. The way that I have the coupling caps installed, if we look at just like a regular Model 26 schematic, instead of having them connected to the plates here, I actually have them connected here on the wrong side of the load resistors. So I'm going to fix that, and we'll pick it up from there. So you can see right here, I used these Christmas tree terminal strips here, and we have an empty one on top that we can use. And yeah, the second row here, the middle row, is where the B plus is coming in, and that's where your load resistor is. And I have these coupling caps tagged on that same row, which is incorrect. It should be, you know, where it connects to the tube. So what we're going to do is we're going to run jumpers from the 2 plates of this dual triode up to the top row, and then we'll just move these guys up 1 step. Should be an easy enough fix, and then we'll have to double check to see what's going on here, because I'm pretty sure I did the same thing over here, so we'll do a very similar thing there. So we're going to need to desolder the legs of those coupling capacitors, and I do have the fancy solder wick that's been pre-fluxed, but I find the regular unfluxed wick, after I've added my own flux to it, works a lot better. It's more labor intensive and it's a bit messy, but it seems to work a lot better, at least for me. So, and it's cheaper. This is definitely a lot cheaper, and so is a bottle of flux, which you need to have anyway. So I don't know, try it out. Your mileage may vary. Alright, so I wired the bypass capacitors incorrectly on the pentode as well.
I didn't think you would make the same mistake twice.
And if I was doing this from scratch, I'd just wire them directly to pin 8, which is the plate. But as you can see, there's a bunch of crap in there. So I'm just going to run a jumper from here over to the top lug of this Christmas tree here, and then do it just like we did over here. And then we'll try it again, see if she works. While we're working on the amplifier here in the background, I got this new band I found playing, Rubber Soul, I guess is the name of the band. They sound pretty good. They might have a future. Alright, let's see if that fixed the problem here. Guitar, speaker, power, variac, current limiter. Volumes aren't freaking gonna blast us, in case this works. Got the variac set for like 80 volts from the wall. Here we go. Take 16. That's good. It means our heater circuit's working. Indicator lamp. So it's pulling about 210 milliamps, 17 watts and climbing, as the rectifier tube is conducting. And here we go, going up. 23, 24, 25, 330 milliamps. Can you hear that? I hear some hum out of the speaker. And the wattage is slowing down. Yeah, we're about leveling out at about 28.6, 28.7, 370 milliamps. Yeah! How about that? Picked up my guitar and I did not get electrocuted. Volume knob appears to be backwards. Volume knob's doing something weird. I think there's some errors in the tone circuit and all the switches and shit. We'll have to figure that out. But it works. Sweet. Well, sort of works. There's a lot of bass. Let's try this. We making headway. So I'm going to see what's going on with the volume knobs and the tone stack here. It's, I don't know, it ain't right. That's for damn sure. We'll check out the other one. I'm going to do this off camera because you're kind of bothering me right now. But I will let you know what we find. Awesome. Damn, it works. Prince of Darkness, baby. Alright, I just plugged into the pentode, and this seems to be working much better. Nice. Yeah, Tom Petty be proud. Alright, yeah, so pentode's working. The tone knob works in the pentode mode, so we got to see what we did wrong with the dual triode. Nice. Alright, I plugged back into the dual triode, and I have it in parallel mode, and it's like the middle of the volume knob is the lowest amount of volume, and then it gets high on either side of this. So that's a clue. What that clue means, I have no idea, but getting there, baby. And yeah, she sounds pretty good. We're only at 80 volts from the wall. You know, so we still have another 40 volts to whack into this thing. But yeah, let me figure out what's going on with the dual triode. I see what I did here, and it makes total sense why the volume knob's working the way it is, where it's the quietest at 12 o'clock and loud on either side. It's because we're not sending any signal to ground here. If the other one that is working, alright, we got a connection to ground, but this other side, we do not. Yep, that'll do it. Alright, let me fix that. Okay, before I forget, I promised to talk about why you do not want to use metal vacuum tubes on an amplifier unless you're assured that it is wired to accept them. So here's a regular output section, simplified, of your typical amplifier. So the B+ is coming off of the rectifier tube. It goes to the first filter cap. It goes to your output transformer. Then it goes to the second node of filtering off of this filter cap. And this goes to the screens of your output tubes. And in between that node and the screen is sometimes a 470 ohm or similar resistor. Alright, and a lot of time the way those are wired is there will be a wire from this filter cap to a pin that's not being used on the tube socket, and then the resistor will be connected from that pin over to the other pin where it needs to go for the element inside the vacuum tube. Alright, so for example, on a 6v6, pin 1 and pin 6 on a glass tube, like a 6v6 GT being glass tube, pin 1 and pin 6 go nowhere. On a metal tube, pin 1 is connected to the outer metal shell. Alright, let me show you in my amp here. So, right here, this wire here, going up to here is our screen supply off of the second node of the power supply. I have it go into this terminal strip, and then between the terminal strip and the screen lug on our vacuum tube socket is the 470 ohm resistor. Sometimes what they might do is instead of going to a terminal strip, the wire will come to pin 1, and then this resistor will go from pin 1 over to whatever this is, pin 4. So you got high voltage going to this pin, you slap in a metal tube, and you energize the outer metal shell with 300 volts, which ain't cool. So hopefully that made sense. Okay, back at it. Let's get this sucker going. All right, we've got her dialed up to 120 volts from the wall. Still on the current limiter. It's running at just under 70 watts total output. That's not, output to the speaker. That's total power consumption from the wall. 620 milliamps. She's sucking down a little bit of power. But checked all the functionality. Everything works. Got everything working correctly, and we're almost ready to try her out with a real speaker instead of this shitty crate bench speaker. But yeah, sounds pretty good. Alright, let's hook her up to a real speaker. She's pretty quiet, actually. With the guitar next to it, obviously, it makes a bunch of noise, but guitar volume down, well, turn the guitar volume up. Very quiet. And there's a lot of interference from my computer and stuff, but that's with the volume all the way up, guitar volume all the way up. No hum, just a little bit of... But that's what we like about these things. Alright. Let's get a good speaker on here and see how she sounds. Alright, we got her hooked up to this cabinet, which has an Eminence Legend 1058 in it, and she's sounding pretty nice. There's a little bit of noise on the pentode side, cranked all the way up, a little bit of hum. But, yeah, it's the grand scope of things. It's barely noticeable. Yeah, there's some, whatchamacallit, it's a little bit microphonic. But that's to be expected with a pentode preamp tube. But we'll roll some tubes in there, see what we can come up with. But yeah, she sounded pretty sweet.
We are but men, rock.
Oh yeah. Life is good. Buddy. Well, there you have it. I'm not going to bore you with a bunch of licks, just through the camera phone audio. We will do some demos. We'll put it on the Rubble dyno, but I'm going to call this a success. We might do an after-action report as I, take her with it and stuff.
Busy.
But I'm sure this video is already 6 hours long, so we have succeeded. We have a Prince of Darkness amplifier.
Who are you?
I was just about to end this video and I totally forgot why we're here. We're here for the metal tubes. Alright, we have all metal tubes in here. I checked the bias. Here are the numbers, but the bottom line is 13.5 watts of plate dissipation. 6v6 on a cathode biased amp. Maximum is 14, so we freaking nailed it. First shot. Alright, let's wrap this up. Well, there she is. Isn't she beautiful? I think if I were to do this again, I'd use black hardware. But I don't mind the chrome looking stuff. I may go back to the skirted black knobs, or not. Depends. We'll have to see when after we build a head cabinet for this. Yeah, baby. The Prince of Darkness.
Cadwallader's my name.
Love it. Alright. I hope you enjoyed the video. I want to thank you for watching. I want to thank the Tone Princess for inspiring this video. I want to thank the Tone Nun for putting up with my bullshit. And I want to thank all the subscribers. We got a whole bunch of new subscribers. Thanks, subscribers. Thanks for subscribing. I hope you enjoy what we do around here. We're just getting started. We're just starting to get legit at this shit. So stick around. Come on back, see what we're doing. And yeah, thanks for watching. Thanks if you made it all the way through this friggin' marathon movie I made. And we'll see you soon with some demos and the Rumble Dyno and all that fun stuff. But until then, rock on.
Thank you.